Okay, folks, I just want to give you all a brief overview of this lesson. This first part is how we would do a one sample z interval for population mean. The problem is that we never in reality use this because we wouldn't actually know the population standard deviation. How could we possibly know the population standard deviation if we don't know the population mean? However, sometimes you will have a multiple choice question on the AP exam where they do give you the population standard deviation, and this is how you would, this is the formula you would use. So that's what this part down here is showing you. If they give you the margin of error, they give you the confidence level, they give you the, and they want you to find the sample size, this is what you would do, and you would still use the Z star for your critical value, not the T star that we're going to be learning about later in the lesson. All right, so moving on, T distribution. So where in the world did these come from? All right, again, so when we go to standardize, the formula would be as shown in my box right here. But the problem is we don't actually know the population standard deviation. So we have to estimate it with the sample standard deviation. And when we go to do that, it kind of changes the distribution a little bit depending on the sample size. So I'm going to pull up the applet and show you what happens right here. All right, so this applet is the same one that was we used a couple of days ago, and it is in your Google Classroom. So you can look over to the left. All I've done is set it at means, normal, and I'm doing Z with sigma. My mu is 100, my standard deviation is 5, and my sample size is 4, and I'm going to pull 100 intervals. Okay, so when we do this, we can see that in this case, 93% of the intervals contained mu. All right, so what we're going to do now is we're going to redo this, but this time we're going to do Z, but with the standard deviation of the sample. And in this case, we can see that only 86% of the intervals contained mu. So then we're going to change it, and we're going to do it with T. And when we do it with T, we can see that 98% of the intervals contain mu. Okay, so when we did that simulation with a confidence level of 95%, hopefully what you could see is when we use T and the standard deviation of the sample, that was the best match. So the T distribution matches best. All right, so let's learn a little bit about the T distribution. Okay, so the T distribution looks very much like the normal distribution. It's still symmetric with the peak at 0, but it has much more areas than the tail. So it's kind of like if you pushed on the top of the normal distribution and pushed it down a little bit. That's what the T distribution would look like. And the T distribution is created by depending on the degrees of freedom. To calculate your T value, it's the same as any standardized score. You just do your X bar minus mu divided by the standard error. And so you can look down here and look at the different T distributions to see that you have a lot more area in the tails than you would of the normal distribution, and the normal distribution would be the purple one here. Pretty much what happens is the lower the number of the degrees of freedom, or in other words, the lower the sample size, the wider it is. And as you increase the sample size, you increase the degrees of freedom, which ultimately then makes the standard error closer and closer to the true standard deviation, so the T curve gets closer and closer to the standard normal curve. All right, if you need to watch videos, I put some technology videos and a video for reading the table to be able to find your T values. So you can go and do that, or we can talk about it later on Zoom. Okay, so the standard error of the sample mean of X bar is S sub X divided by the square root of N. And this is also on your formula sheet. To be able to calculate the confidence intervals, the name of it's going to be a one sample T interval for population mean. And it's just like the ones we did earlier. It's always going to be in the form of the statistic plus or minus the critical value times the standard error of the statistics. So you just kind of have to substitute those into your confidence interval formula and put it together. All right, so here's some of the big things that we have to make sure that we check for. The population distribution is normal, or the sample size is large, which will allow us to say it's approximately normal. And then also the population is at least 10 times as large as the sample. So there's our 10% condition. And then here's our normality condition. And then we also, of course, have to make sure it's random. I'm going to skip to the end real quick to talk about when the sample size is not large. Make sure that you read the definition for robust. You'll see that term pop up quite a bit on multiple choice questions and just in other places. So here's the deal. If you end up with a sample size that is less than 15, what you have to do is you have to graph the data. And Mr. Mayo always says just use a dot plot. It's easy. It doesn't have to be perfect. Just do it real quickly because it's less than 15 values. As long as it's roughly symmetric, unimodal, no outliers, nothing that's extremely skewed or anything like that, you're pretty good to go, and you can use the t-distribution. If the sample size is between 15 and 30, as long as it doesn't have outliers or strong skewness, you're good to go. And then for anything that's greater than 30, you do not have to graph it. But for the other ones, you do have to graph it, and you have to make sure you include the graph in the problem. All right, so going to the one about the toilet paper soaking up the water, we do our state, and then in our plan, make sure you state the name of the interval you're using. So a 1 sample t interval for population mean. Check your conditions, random, because it says random sample, independent, there's your 10% condition, and then normal. Because n is small and the distribution is not specified, we need to check for normality. This is really, really important. So what we've done down here is a dot plot, because the dot plot does not show any outliers or strong skewness, and sample size was 18, so between that 15 and 30, we can assume a normal population or approximately normal population, and the conditions are met. Very important that you actually put this graph on your paper. All right, so then the do part. When you do the do part, make sure you always write down your mean, that you write down your standard deviation, and that you write down the degrees of freedom and the t-star. Especially if you ran out of time and you're not going to end up having time on the AP exam to get the formula written out, make sure you write this stuff. You can, if you watch the little video or read the book, when you put this data in your calculator, you can do the t interval right there from the data, and it'll also give you these values. Just make sure you put them on your paper. And then, of course, we use our mantra. We are 99% confident that the interval from 22.99 to 26.89 captures the true population mean number of squares of toilet paper needed to absorb 1/4 cup of water. Make sure to watch the little video about using table B to get your t-star, your critical value, because it really helps to explain that if the degrees of freedom does not appear in the table, you use the greatest degrees of freedom that is less than your desired degrees of freedom. That's really, really important. That video is really short. All right, and then here's the one on the check your understanding about the true mean healing rate. Same thing, because the sample size wasn't greater than 30, we had to do some type of graph, and I just pulled this one. Honestly, that probably would be a lot to draw on your paper, so I would do either a dot plot or a box plot if it's between 15 and 30, something that's quick to draw. And there's a video also in the Google Classroom about being able to pick out if it's okay, if we can say it's approximately normal or not. And then make sure you do all the steps and do your mantra. And we will try to get together later and discuss anything that we need to discuss. Going to the practice problems at the end. Numbers 71 and 72 are full problems. Those would be great problems for you to do to practice the full state plan do conclude. And number 73 is a sample size problem that we discussed at the beginning.